we are going to discuss about normal rake system. Okay. So this system is known as ISO new, whereas orthogonal rake system is known as ISO old. Normal rake system is known as ISO new. Limitations of orthogonal rake system are overcome by using normal rake system for description and use of tool geometry. What are the limitations of orthogonal rake system? So in previous class we discussed what are the limitations. Ninpidya, what are the limitations of orthogonal rake system? If you know, you can answer. ಗೊತ್ತಿದ್ರೆ ಆನ್ಸರ್ ಹೇಳ್ಬೋದು. Okay, so the limitations of orthogonal rake system are, so it is not possible to visualize, or it is not possible to get the true picture of the cutting tool geometry. So what is the reason for this demerit? So that means because of the inclination of the rake surface, there will be an inclination angle. Because of that inclination angle, it is not possible for us to get the true picture of the tool geometry. Okay, so that is one of the disadvantage. Other than that, there is another disadvantage. Some additional calculations may be required. So if you follow orthogonal rake system, so these are the two major disadvantages or limitations associated with orthogonal rake system. One is it is not possible to get the true picture of the tool geometry. Another limitation is additional calculations may be required. Okay, so those two limitations are can be overcome with the help of the new rake system. How? So that we will discuss in today's session. Okay, so the basic difference between ORS and NRS, that is orthogonal rake system and normal rake system, is the fact that in ORS, rake and clearance angles are visualized in the orthogonal plane. So by taking some of the views, sectional views and views in different directions, so we saw where we are going to get this rake and clearance angles. In case of ORS system, so we are able to visualize rake and clearance angles on orthogonal plane, whereas in this case, that is normal rake system, so those rake and clearance angles are visualized in another plane called normal plane. So since we are able to visualize rake and clearance angles on normal plane, this system is called as normal rake system. The orthogonal plane, that is denoted by pi O. O means orthogonal. Pi O is simply normal to pi R and pi C, irrespective of the inclination of the cutting edges. So that is, there will be some angle, inclination angle denoted by lambda. But so this normal plane, okay, so normal plane is always normal to the cutting edge. Okay, so this sentence you can understand by looking at the figure in the next slide. Okay, here. So in order to understand this, so you must know about orthogonal rake system that we discussed in the previous class. Okay, so in case of normal rake system also, there will be a horizontal plane that is not indicated in this figure. So there will be a horizontal plane, okay, that is not indicated. So there will be horizontal plane. That horizontal plane is called as, again, normal reference plane. So on the horizontal plane irutte, so that is not indicated in this figure, but there will be a plane, horizontal plane. So that is called as normal rake plane. So other than that, so this figure is used to identify the difference between normal rake system and orthogonal rake system. Okay, next, so cutting plane. So in case of ORS also, this is the cutting plane. In case of NRS also, cutting plane is same. So this is the cutting plane. This cutting plane is taken along the principal cutting edge of the tool. So this is the principal cutting edge, and you are taking this plane along this principal edge. So vertically, if you move to visualize the plane, so this will be along the principal cutting edge. Okay, so it is same for both the cases. but the major difference that you must be able to identify is this plane. In case of orthogonal rake system, so there will be a plane, there will be orthogonal plane like this. This plane is perpendicular to the reference plane and it is perpendicular to the reference plane, and it is also perpendicular to the cutting plane. So in case of ORS, so there will be orthogonal plane which is perpendicular to both reference and cutting plane. But here in case of NRS, that is normal rake system, we are going to consider an additional plane. Okay, so that additional plane is represented by this line, this. Okay, so this is the normal plane, this one. Okay, so now you have to carefully visualize the angles. Okay, so what is the angle between orthogonal plane and reference plane? So here you can see, so the angle between orthogonal plane and this line will represent the reference plane. Okay, so this is 90 degree, whereas so in case of normal plane, so this is this inclined line, this line represents the normal plane. Okay, so the angle between normal plane and major cutting edge, so we are considering major cutting edge. Okay, so this angle is 90 degree. If you consider the angle between major cutting edge and orthogonal plane, so it is not 90, it is not perpendicular, it will be more than 90 degree. Okay, so here you can see, so from orthogonal plane, this plane, orthogonal plane to reference plane, okay, it is 90, but if you consider orthogonal plane and major cutting edge, so it is more than 90, so that means 90 plus lambda, so that will be the angle between major cutting edge and orthogonal plane. Okay, but so if you consider the normal plane, this normal plane is perpendicular to major cutting edge of the tool. So here that is indicated here, this one. Okay, so here normal rake system means you are considering or you are tilting this orthogonal plane to an angle lambda. So you are tilting this vertical plane, that is the orthogonal plane, to an angle lambda such that so this normal plane will be perpendicular to the major cutting tool edge, major cutting edge of the tool. So you are tilting this plane such that this plane is making an angle of 90 degree with the major cutting edge of the tool. Okay, so this is about the normal plane and normal rake system. Okay, instead of having a vertical plane which is perpendicular to both reference and cutting plane, here in case of NRS, normal rake system, you are having a vertical plane, that is normal plane, which is perpendicular to the principal cutting edge, this one. Okay, so again, if you extend this orthogonal plane, okay, so that will meet the rake surface at a point B. If you extend this normal plane, this will meet the rake surface at a point C. Okay, and this is gamma n is the normal rake angle. This is gamma naught is the orthogonal rake angle. So this is orthogonal rake angle and this is the normal rake angle. Okay, so next, same thing, if you visualize from top, so you are going to get this. Top view will be on the reference plane. Okay, so this is the top view of this tool, and then so you are taking the view or you are taking the section here on this plane, so that you are going to get this. Okay, and here also lambda, we discussed in the previous class, lambda is the angle between the rake surface or major cutting edge, which is also part of the rake surface, and the reference plane. So this is the lambda, and it is called as inclination angle. So this is in case of orthogonal rake system. Whereas, so if you take section along A and A, okay, and if since here, so you are going to tilt this plane for lambda in order to get the normal plane. Okay, so in order to get the normal plane, we are tilting it for lambda. So because of that reason, we are taking section. Okay, so like this, A and A. If you take section along this cutting plane A and A, so you will get this sectional view, and this is along the normal plane. So this line represents normal plane in the top view. In top view, it will represent the normal plane. So on the normal plane, so if you take section, so you are able to visualize the rake angle, normal rake angle, and you are able to visualize the clearance angle, that is the normal clearance angle. Okay, so rake angle means it is the angle between the rake surface and the reference plane. Okay, so clearance angle means it is the angle between the, okay, so flank, that is clearance surface, and the finished surface. So the finished surface is indicated by the, so cutting plane. Okay, so that's why you are taking this as clearance and this as the rake angle. Okay, so this is such section along this direction. Okay, so if you take section along the orthogonal plane, so you are able to visualize rake and clearance angles on the orthogonal plane. Okay, so do you have any doubt? So another doubt is, yeah, if you have any doubt, you can ask. If you have doubt, so you can ask. Otherwise, I will move on to next slide. Okay, so the planes of reference and the coordinates used in NRS are phi Rn, that is the normal reference plane. So in this figure, you cannot see that normal reference plane, but it will be the horizontal plane as in the previous system. So that has not been indicated in this figure. Okay, so horizontal plane is the reference plane, that is denoted by pi Rn, normal reference plane. Pi c is the cutting plane. Phi n is the normal plane. So normal plane means plane normal to the cutting edge. So here in case of NRS system, instead of orthogonal plane, instead of a plane which is perpendicular to cutting edge and reference plane, you are having a plane which is perpendicular to the cutting edge, not to the reference plane. So this normal plane is not perpendicular to the reference plane. This normal plane is perpendicular to the cutting edge. Okay, so that is the major difference between ORS and NRS. So here xn, yn and zn are the coordinates. So xn is same as xo in case of orthogonal rake system. So we consider that as xo, that is orthogonal. So in case of normal, we consider that coordinate as xn. Similarly, along cutting edge, okay, the axis along the cutting edge, we consider that as yn. And then normal to both xn and yn, we consider that as the zn, that is along the velocity vector. So if the lambda angle, okay, the only difference between NRS and ORS is presence of this lambda angle. Okay, so it is to be noted that when lambda is 0, if the lambda angle, inclination angle, so that is the angle between reference plane and rake surface or major cutting edge, okay, if the angle between reference plane and major cutting edge is 0, that is called as the inclination angle. If this inclination angle lambda is 0, then there will be no difference between NRS and ORS. NRS and ORS become same. So that is orthogonal plane will be normal plane. Okay, so no need to tilt the orthogonal plane to an angle lambda to obtain normal plane. That is not required. This orthogonal plane will itself will become normal plane. If so the rake surface is flat. If the rake surface is flat, then lambda will be 0. Okay. Next, yn will be equal to yo, zn will be equal to zo. Okay. So because of this lambda, so there will be nrs and ors. Okay. So if it is 0, then both are same. Okay. So rake angles in nrs, so denoted by gamma n, normal rake angle, angle of inclination of the rake surface from reference plane and measured on normal plane phi n. So clearance angles, normal clearance angle, angle of inclination of the principal flank from cutting plane and measured on normal plane. Okay, so then axillary clearance angle, angle of inclination of the axillary flank from the axillary cutting plane, denoted by phi c prime. So and it is measured along the axillary normal plane. So that is the plane normal to the axillary cutting edge. Okay. So the cutting angles, that is phi and phi 1. So side cutting angle are principal cutting edge angle and end cutting edge angle. Okay, so are same, and nose radius also denoted by r, and it will be in millimeter, are same in ors and nrs, no changes.